exploring brass bowie port and meet Chimney scissor sticks. Chimney tells us about the captain's new software-defined radio, which the captain is using to monitor suspicious transmissions. The SDR uses JWT tokens for authentication. Our objective is to review these suspicious transmissions and intercept their go date and frequency in order to alter their plans. We open the game and notice we cannot access the SDR waterfall console or the transmitter. Each requires a specific role to be assigned to us. We also find a variety notes which contain hints for how the SDR works. That certainly is a lot of clues. As we find these hints, we write them down to keep better track of them. We will keep our list of hints on the left of the screen. As we progress, a green dot will indicate which hint relates to the different parts of this challenge. By reading this hints, a solving strategy starts to take form. During deployment, a few tokens get automatically generated. This includes the R monitor and R decoder tokens. Obtaining these tokens should allow us to access the SDR system. We will start there. With the Chrome Web Console open, we go back to the SDR and attempt to access it once more. This generates the check roll request under the Network tab. By reviewing this request, we find reference to the authentication bearer hint. This authentication section of the header contains a JWT token. Notice how this token contains all three parts: a header, a payload, and a signature. As this request seems to contain the expected authentication header, we copy it as curl. This gives us a request we can modify to obtain different elements of the challenge. We open our terminal and paste the curl request. Next, we modify the URL to target the location of the R monitor token, which was given to us in the hints. This request successfully returns the R monitor token. With this token on hand, we navigate to the Application tab in the Web Console and modify our Just Watch This cookie with the value of the token we retrieved. Back in the game, we can now open the waterfall console of the SDR. However, we are required to have the R decoder role in order to view the signals. We bring back our terminal and submit a new curl. This time, the target will be the R decoder token in the JWT default folder, and we will be using the token we obtained for the R monitor role. This request successfully returns the R decoder token. Once again, we go back and update our JWT cookie with this new token. Back in our game, we test and confirm we can open the signals. The first signal is a number station transmission. The message is padded with music and tones. A closer look reveals the date and time values we were looking for. In this case, the date of 12/24 and the military time of 1600 are padded with a number 9, and each message is repeated twice. We review the second signal, and this one reveals the name of the folder containing the captain's private key. Our last signal is the radio fax decoder, and it reveals a map of Geese Islands as well as the frequency used for the suspicious transmissions. Now that we have obtained the information we need to send the transmission, but we cannot access the transmitter. The warning says this access is only for administrators. As we have learned, the JWTs used by this application are signed, and as such, the only way we could impersonate the captain is to obtain the private and public keys and sign our own JWT token. We start by retrieving the public key as its location and name were given to us in our hints. To do this, we go back to our terminal and resubmit the curl request using the R decoder token we obtained earlier. But this time we aim at the caps pub key file. With the public key ready, we now need to find the private key. Earlier, the CW decoder gave us the folder path for this key. The name of the file is easy to deduce by following the naming convention used for the public key. We then craft another curl request using the same R decoder token from earlier and aim it at the found folder and the caps priv key file name. We have successfully obtained the necessary keys to sign our token. Next, to better understand these tokens, we take one and decode it using CyberChef's decoding widget. The view of the decoded token tells us we will need one additional piece of information in order to generate the token. To find the appropriate role to be specified, we go back to the clue provided at the end of the elf hunt game. This entry from the captain's journal reveals their title, and this is the role we will use to craft our token. We will leverage the jwt.io site to create our JWT token. Using the decoded token in CyberChef, we copy the header as is. We then copy the payload but modify the role from radio decoder to Geese Island Super Chief Communications Officer. We then paste the values of our public and private keys to generate the token. We go back to the Applications tab of the web console for one last time and update the value of the JWT cookie with the token we just generated. Having this super elevated token in our cookies, we go back to the transmitter and send the transmission changing the time of attack. We successfully thwart the miscreants and solve this challenge.